Hello, a couple of years ago I made a video where I was trying to use an Arduino and a simple MPU 6050 gyro to do a very simple attitude hold for plane. Not altitude, as some people have commented on this. Attitude, it's like the orientation relative to gravity, I guess you could say. Just to make the plane hold itself level in flight for a while. Well, indefinitely, hopefully, but my goal at that time was just so that I could take my eyes off the plane every now and then and, adjust my goggles or whatever. That was my main goal. But it never really worked out, and I tried a couple of methods, and we'll look at those in a minute, but eventually I just sort of gave up on it. It wasn't really working out. And sometime after that, at least I think it was after that, hope it was. Oh, no, it was before 2016. So this, I didn't realize that. This code by Yorp Brocking that he made already existed at that time, so I should have just looked at this back then. I only just realized that as I sit down to make this video, that it was already available. Damn. Well, anyway, just recently I thought I'll have a look at Yorp's code and see what he's done to make his multi-rotor fly auto level, because it worked out quite well for him, and he's using basically just the same stuff, MPU 6050 gyro and an ordinary Arduino. And I had some comments on this video. People were saying, why doesn't this work? Because on multi-Wii and things like that, it does work quite well. And anyway, so let's have a look at the code, and we'll see a couple of problems. We'll look at my code first, and I'll show you why that wasn't working too well. This is actually the second version of my code. The first version I don't have, but all I was doing is a simple complementary filter using the gyro and the accelerometer, and I was using far too much of, I should probably explain what the problem was with my system. So let's have a look at this. Some of you may have already seen this, but what it does is it just never really sits on level. It always just sort of drifts away from it. And I think part of the problem is that when the plane is turning, it no longer has a proper sense of true gravity, because gravity from the plane's point of view will be more or less straight down towards the bottom of the plane as it sits in the air, rather than to gravity. So anyway, for that reason, that's why I gave up on that one. Sorry, I'm in a bit of a hurry here because I'm in the middle of power cuts. We're having really terrible weather again. Basically, since the end of July, we've only had about 8 nice days, and the rest of it's been rain and bloody gale force winds, so it knocks out my power all the time. Anyway, let's get on with it. So in the first version of this, I was just using a very simple complementary filter, but I was using far too much of the accelerometer input into the filter. And when I saw Yorp's video, I noticed he was only using a tiny little bit, and he was relying on the gyro integration to do most of the determining of how the plane was oriented. So yeah, that was my first code. I don't have that one here, sorry. And the second version of the code, this is what we're looking at here. I tried to use something, it's been a while and I don't remember where I got it, but I'm including this file here, so I'm assuming that's something I downloaded off the internet, and that gave me functions that let me do this: get quaternion, get gravity, and get yaw pitch roll. And I didn't really look into the source code of that library to see what it was doing, but unfortunately that gave me pretty much the same result as I already had, if I remember correctly. So yeah, so at that point I gave up. Anyway, let's look at Yorp's code, or this is Yorp's code that I've modified for plane, and we'll see what it's doing differently. The main thing, well, there's two things. If we look at how much of the accelerometer input he's using each time step relative to the gyro, it's almost nothing. So it's 400 thousandths, isn't it? Yeah, 0.0004. And the rest of it is all just coming from the existing pitch that it thinks it has. So this is mainly from the gyro integration. So when I saw that, I thought, oh shit, I was really underestimating or overestimating the amount of accelerometer input that I needed to be using. So that was probably the main thing. And another issue is that I was completely ignoring the yaw reading that the gyro gives us, and I was only looking at pitch and roll. But you also should be looking at yaw as well, and the reason is that yaw can change pitch into roll. So let's say you're flying along in your plane and you're perfectly level, pitch is 0 and roll is 0, okay? and then you roll to the right by 20 degrees. So pitch is 0, roll is 20. Now imagine if you could somehow instantaneously yaw the plane 90 degrees to the right. If you could do that, it's probably physically impossible, but on a quadcopter it's close. Yeah, you can get something close to that. But that would make your pitch, now you would be nosing down, so you would be -20 pitch, and the roll would be 0. And that happened because the yaw changed. So if we look at this little bit of code here, I've actually modified this a little bit. There's a little bit of a mistake in this part. This is basically the only part of the code that I could find that wasn't probably just right. So these two lines here is what it was originally. So we take the current roll, and if the gyro is reading a non-zero yaw, in other words it's yawing in one direction or another, that means that we have to take some of the roll and put it onto the pitch and vice versa. And the only reason that I've changed this a little bit here is because what happens here is that the pitch is being modified in this first line, and then the modified pitch is being used here, which is not quite right. And I think in practice that doesn't really matter, because this change only has effect when you have quite a large pitch or roll angle to begin with. So if you're flying along in level flight with your quadcopter and you do a sharp yaw, this is really not going to make any difference. And the other thing is, there was another reason too, but yeah, basically in practice you don't encounter this situation very often, so it doesn't matter too much. But nonetheless, I thought I would just fix it like that with a temporary variable. And I only noticed this because I was holding the flight controller board in my hand and spinning it round to see what kind of numbers it gave. And I found in some situations the increase that the roll got was twice as much as it should be. And I think that's because of this number being used like that. So anyway, let's just have a look at some footage that I got testing out the original unchanged YMFC-AL code, just to check that everything was working before I tried to put it onto a plane. To use as a test bed, I quickly whipped up this wooden quadcopter frame, just like the old days. Well, actually, not really just like the old days, because I've taken to designing it in CAD and printing it and using the scroll saw to cut it out and stuff these days. So I'll leave a link to this in the description if anybody wants to try it out. You will need some standoffs like that, 3mm or M3 screws, and I'm using 1/2" wood to make the arms out of. On the ends to mount the motors, I haven't put that in the plans here, of course, because it'll depend on what you want to do, but I'm going to use some things like this. Or if you're feeling game and the motors that you are using have the C-clips recessed like this so that the bottom of the motor is all flat and there's nothing sticking out, you can actually just use screws for example the 19mm spacings there, and if you get the holes just right, good luck, but if you can get it just right, you can just screw into the motor from below, and that's a fairly lightweight way to make it. It's about 110 grams as it sits here, and I'm planning to make the positive and negative sides of the PDB, so to speak, separate on the top and the bottom of this, which is why there's not really any big holes in the middle to pass wires through. There's just this fairly small one there, but I'll put it together a little bit and show you what I mean about that. Flying great. I haven't really tuned it that much. I've probably done about 7 or 8 iterations of just changing some parameters. It really needed the P and the D reduced quite a lot, And there's still a sort of a strange issue where if I change the pitch of the roll quickly, it sounds a little bit stuttery. I don't know if you can hear that, but it's just until it meets the set point. If the set point is fairly far away, it will do that, it seems. But other than that, it's flying really good. And I haven't noticed any issues with the when you do rather fast throttles like this. It's really smooth. Seems to be a lot smoother than I remember the original YMFC version being a few years ago when I tried it. So I'm not sure if that's to do with the frame that I've built here being a little bit better aligned or what, but it's very smooth like that. And yaw is pretty rock solid too. It's just sort of getting away from me there because of the wind, I think, but yeah, it's great. So I'll probably just leave it here for this test that I'm doing. Just wanted to make sure everything was okay before I moved on with the other frame type that I'm trying to do. What's this problem? Alright. There we go. So it's very simple. Just a few pieces of wood, some motors and ESCs, Arduino Pro Mini and a gyroscope and a receiver. And that's it. Oh, and a battery, of course. Very simple. Just doing a little test to make sure everything's okay after I did a slight reconfiguration. I decided that rather than using a Pro Mini and a separate gyroscope board, I'd go back to using this old friend that I haven't seen for a while. This is the original cheap-ass quadcopter board that I used. It's basically a Pro Mini with a gyroscope and a compass on there. And it is now reunited with a wooden quadcopter for the first time in, I don't know, 4 or 5 years. Okay, so that worked fine, and it was very, very easy to set up, and all the instructions are in Yorp's video here. There's actually a couple of different sketches you need to use. You upload one of them first to do some calibration and settings of, you know, which direction your channels are going for the receiver and everything. And then the flight controller itself is in a separate sketch, which doesn't do any serial printing or anything that's going to slow it down. And it's all very simple. All you need to do is load up that first sketch and follow the instructions on the serial monitor, and it was so easy actually. To be honest, I didn't want to do this with Arduino to begin with, so what I did was I took Yorp's code and I tried to port it to Mbed. That's the online compiler that you can use to write programs for STM32 boards, and I spent 3 days trying to get around an issue that I had where you couldn't use the fast I2C clock of 400 kilohertz and also have PPM inputs coming in. They would interfere with each other. So after 3 days I just gave up on that, and I went back to Yorp's code, and again I was like, why didn't I just do this the first time? Because within about 2 hours I had everything working, and I was just kicking myself for not doing this to begin with. So to change that from controlling a quadcopter to controlling a plane wasn't really too much to change, to be honest. So this is the original code here that I've commented out, and you have your 4 ESCs, and they are controlled like this. So you, excuse me, you have throttle, and then you add or subtract, depending on which corner of the quadcopter this motor is on, the output from the pitch, roll, and yaw PIDs. They run separately, and so that's the output that you get there to the ESCs. And just above that I've put the output. So this is my new code that I've added, and I've also made it so that there's a 5th channel of the receiver being used as a switch to say whether I'm running in auto level or manual switch, like this switch. So that's what receiver input 5 is. And if we are just running in manual, we take the servo pulses directly from the receiver input channels 1 and 2, so that's roll and pitch, and I've just subtracted it from 3000 to reverse it because I needed to reverse that input on my in my situation. And then we do an elevon mixing, which is in another function, but that will just convert these pulses to what they would be for elevons. And if you don't want elevons, if you just have normal pitch and roll plane, like a conventional layout, I was using a flying wing, that's why I have it this way, you would just comment that out, and then you would the pulses would be just left as they were. So if the switch is high on channel 5, then we change it a little bit. So instead of using the direct receiver inputs, we're going to be using the output from the PIDs for roll and pitch. And then down here, I've also changed this to have 6 outputs because I'm going to be making something a little bit different with this in the future, hopefully. That will need 6 outputs. Actually, no, it might not. But anyway, there's 6 there. And just because of the way my board was arranged, I had to plug them into different pins so that I could get the lid on my C1 chaser. It wouldn't fit on otherwise, so I just had to move them over to different pins like that. But anyway, that's how it works. So the third channel, or the 6th one I guess here, this is just directly taken from the throttle channel, which is channel 3, and I had to reduce this by 20 because it was giving me values of about, it was giving me typical values of 1008 at the lowest point, and my ESC on my plane didn't want to recognize that as low, so I had to reduce it so that it was less than 1000 to stop the ESC from complaining. And that's it though, really. So this is what I'm going to show you next of that video, and like I say, the weather here has been really shit. So it wasn't very inspiring weather-wise, but I had to go out and do it before it started raining again anyway. And just to look at the PIDs that I ended up with, I'm not doing anything for yaw. I tried it a little bit, not in flight. I just tried it, at the bench to see what it would do, looking at the elevons to see how they moved, and it just seemed to be causing trouble. So I left the I term as 0 for both of those. The yaw PID is completely not playing any part in this, by the way. It's just a flying wing, so there's no rudder. And I've ended up with quite a bit more gain on the roll than the pitch, as we'll see in the video why that was necessary. And we'll also see in the video that these values, as I left them at the end of the video, are still a little bit high, I think. So maybe the D could come up a little bit, I'm not sure, but I'll play with these a little bit more in future, weather permitting, of course. But that's probably all I really need to show you in the code. It wasn't really changed that much. So let's just look at how this turned out on the plane. Here's everything set up on the plane, ready to go for tomorrow morning. I'm going to use the C1 Chaser for this. A great plane, one of my favorites, if not my all-time favorite, probably of at least of planes that I didn't make myself. Every now and then somebody asks me for a recommendation of what's a good plane, and I pretty much always say one of these. This is actually my 3rd one now. You can see it looks nice and clean. This one has actually not been flown yet. My first one is looking pretty shabby these days. The second one I actually smashed beyond repair in the maiden flight, which was a bit of a bummer.
Oh my goodness.
Oh, that was manual mode! I thought I was in fly-by-wire.
Oh my goodness.
Anyway, so this is number 3, and this is what everything looks like in there. Just have that flight controller thingy on the top on a piece of plywood, everything stuffed in underneath it, and all the trims and stuff I think are in the right directions and ready to go. Well, the response is a little bit excessive, I think. Might be a bit sort of twitchy in flight, too much pee, but we shall see how it goes. Whoa. Okay, rates are too high all round, but it's flyable. Switch into auto level mode. Yeah, look at that. Okay, well it's working, but the rates are way too high in pitch at least. Let's give it one more try. Okay, I'm able to steer it around, but obviously that's not good for anything in the long run, so I'm just going to have to go back to the computer and set it up properly. Okay, I reduced the P a little bit and I added some D just in case that could be helpful. Okay, here goes. Oh, it's still too much, huh? But it's doing auto level. See, my stick is fully over to the side this whole time. When I let go, let's see if we can land it in auto level mode. Well, that's pretty smooth. Look at that. There we go. A little bit of flutter and pitch there still. Alright, I'm just gonna full right stick. It's losing height, let it go. Looks like the pitch gain is still a little too high. Oh, the roll gain's high occasionally too. So they're both still a bit high. Or is it? Actually, it looks like mostly roll is too high here at the moment. Oh, that was a feisty one. Completely downwind. The wind's perfectly coming at me here. Oh, there we go. That's it. So just the gains were too high all around, huh? Right, a little bit to the right. Full right. And let it go. I can't actually see very well what attitude it's holding there, but I'll be able to look at it on the video afterwards. It's climbing, isn't it? Oh, it's not like you could tell. Why am I asking you? It's climbing, alright. Alright, so let's do a full left turn here. Oh, that's pretty good still. I was worried that when I reduced the P gain, the roll would not be very responsive, but it's pretty good. It's climbing again, I think. I wonder if I can just bump the throttle down to stop that. Looks pretty good actually. Alright, full left. Let go. Full left again. Let go. Full left. And let go. And there's probably a lot of lift coming up here right now, so it's probably going to climb a bit again. That's okay. It's holding pretty steady. It's tending to yaw to the left a little bit. Let me see if I can... Oh, that might just be the wind actually. But as far as holding level over a long period of time goes, it's a lot better than that old version that I was using a couple of years ago. Way, way better. Let's try a glide. Hey, not bad. Wow, this is working quite well. Just doing a long glide here into the wind. Hands off the whole time, just sort of keeping an eye on it. But I'm already starting to feel quite comfortable with not looking at it all the time. Let's do a fast low pass. Okay, so it fluttered there when it picked up a lot of airspeed. See if I can give it a bit of full throttle here. Yeah. Okay, so high airspeed still flutters. Alright. Alright, well I think I'll leave it here for now, but I'm quite happy with how it's going so far. It's looking really promising. It's certainly a lot better than my code that I was using a couple of years ago. If I do some other stuff with this in the future, I'm actually thinking that I might try adding a GPS and making a simple return to home kind of feature. So the GPS would just try and figure out which direction the plane's currently moving in, and if it's going the wrong way, it will just sort of nudge it nudge it slowly around like this until it's heading in the right direction. So it wouldn't be good for getting up close. Like once it gets to the home point, trying to loiter around is another story. But if you're a long way away and you just want to go in a straight line to a certain point, that's mostly what return to home you want it to do until you get back into radio reception range. Anyway, that sort of a return to home, a very, very simple one, shouldn't be too difficult. So if I give that a try, I will let you know how it goes. Anyway, until then, thanks for watching. See you next time.